To calculate the probability of having Eileen and Ben in the committee, I need to calculate the number of ways that particular event can occur. So what happens is, to calculate the probability of having Eileen and Ben in my committee, well, there's only one way to have Eileen in the committee, and another one way to have Ben in the committee. And then I choose 5 more people, or 3 more people, to fill up my committee. So I need to create combinations of 3 out of the 7 remaining options. So once again, I'll pull out my calculator and ask for 7, C, 3, and I get 35. So my probability would be 35 over 126, or approximately 28%. Now, let's look at question B. What is the probability of ending up with exactly 3 women and 2 men? Well, here, I'm choosing 3 women out of a possible 6. So the first thing I do is calculate 6C3. And then notice I have an AND situation here, so I'm going to multiply by the number of ways I could choose 2 men out of the 3. So 3C2. So first, 6. C3. That gives me 20. And then 3. C2, which gives me 3. So we have 20 times 3, or 60, over 126, which is about 48%. For our final example, here I need at least 3 women. At least 3. That wording means I could have 3 women, or 4 women, or 5 women on the committee. So we've already calculated what it would mean to have 3 women from option B, and that was 60. To calculate 4 women, I would have to use 6C4 and then multiply that by 3C1 to fill that remaining slot of the 5 with 1 man. 5 women would be 6C5, and then multiplied by 3C0. Now we know there's only one way to choose 0 out of 3, so 3C0 is going to be 1. So let's see what we get for our other calculations. 6 C4 turns out to be 15. 3 C1 turns out to be 3, which makes sense. There should be 3 ways to choose one of the 3 men. And finally, 6 C5 turns out to be 6. So 6C4 turned out to be 15. 3C1 turned out to be 3. 6C5 combinations, which was 6, times the one way of choosing no men, which gives me 6. So to calculate the total number of combinations of at least 3 women, I would have the 60 for exactly 3, plus 45 for exactly 4, plus 6 for exactly 5, which gives me a total of 111, which would mean that my probability would be 111 over the 126. Let's recap. What is the defining characteristic of a combination? Well, as we saw, in a combination, order doesn't matter. What are some key words that indicate combinations? Well, things like forming a committee or a group. For a given subset of objects from a set, will you have more permutations or combinations, and why? You'll have more permutations because in a combination, each combination contains additional permutations of the subset. How do you calculate combinations of a limited number of objects from a set manually? Well, we use our formula. NCR equals n factorial over r factorial times n minus r factorial. How do you calculate combinations of a limited number of objects from a set with your calculator? We use the math menu, go over to probability, and use option 3, NCR. What is the mathematical formula for calculating combinations? Again, n factorial over r factorial times n minus r factorial. What is the mathematical notation for calculating permutations and combinations? We'll be using the notation NPR and NCR.